Today we are going to be talking about how to find volume using the water displacement method. First, we need to remember what volume is. Who knows what volume is? Volume is the amount of space that something takes up. Some students will often confuse mass and volume. Mass is the amount of matter that is in an object. For our activity, we will be measuring volume. True or false? Volume is the same thing as mass. Thumbs up if you think that this is true, and thumbs down if you think it's false. False. Volume and mass measure two different things. Volume is the amount of space that something takes up, whereas mass is the amount of matter that something is made of. It will be important to remember this in our activity. Have you ever jumped in a swimming pool and seen the water flow over the edge? Raise your hand if that has happened to you. Why do you think that happens? All right. The question we want to answer today is, how can we find the volume of an irregular solid object? Well, how do we find the volume of a liquid? We could use a graduated cylinder to find the volume of a liquid measured in milliliters. What property do liquids have that make this possible? Liquids take the shape of their container, and volume is about finding how much space something takes up. True or false? You can find the volume of a solid the same way as a liquid. Thumbs up for true and thumbs down for false. This is false. A solid does not take the shape of its container. If we just look at a solid in a graduated cylinder and try to measure it based on how it appears, it won't be accurate. The solid will not be taking up all of the space in the graduated cylinder, so we will need to use a method called water displacement. We're going to watch a video that demonstrates how we can use water displacement to find the volume of irregular objects. They filled their graduated cylinder up to 48 milliliters of water. Then they added the bolt to the water. What happened to the water? Right, the water rose higher. What does this tell us about the volume of the object we added? In this case, the bolt. Let's see. What operation could we use to find the change or the difference of the water before the bolt was added and after? Subtraction. What would we be subtracting? We would subtract the starting amount of water from the amount of water after we added the object. What would that represent? It would represent the volume of the object that we added. In this case, the bolt. Now, let's try a problem together. This picture shows a graduated cylinder with just water on the left. What is the initial starting point? It is 600. On the right, it shows us the same graduated cylinder after a rock was added. What is the final level of water? The water is at 800. How can we use this information to find the volume of the rock using what we just learned from our video? We can take our final level of water after we added the rock, which was 800, and subtract our starting or initial amount, which was 600. What will this give us? It will give us the volume of the rock. 800 minus 600 is equal to 200. So the volume of the rock is 200. Now we're going to look back at one of our questions from earlier. Have you ever jumped in a swimming pool and seen the water flow over the edge? For those of you who did raise your hand, or those who didn't but have an idea now, why do you think this happens? Exactly. The volume of you going into the water makes the water overflow because volume is the amount of space that you are taking up in the pool. If you want to do more practice, you can go to this website and use the practice problems that it gives you using different objects like the dinosaur. You can even compare the different objects and their volumes. You could also try this experiment yourself at home with an adult and use some items that you have at your house that would fit in a bowl or a glass. You can see if the water rises a little or a lot. Does anyone have any questions? Great work.